Right, welcome back everyone to part 3 of the Mandelbrot series. Today, I finally want to make the whole thing interactable. So before, we've written the code to generate the Mandelbrot set. And in part 2, we've used the multiprocessing library to actually speed up the generation. So for example, this 2000 by 2000 image took me about 9 seconds to generate now with multiprocessing, whereas in part 1 an image like this took maybe 5 or even 10 minutes. So we finally got the speed up we need to make it interactable. And yeah, so today we're gonna do that. And my goal would be something like this. Something where I have the Mandelbrot set, I have some way to zoom in, and maybe move the mouse around, we'll see. And most importantly, once I zoomed in and I'm not happy with the resolution anymore, I can crank up the number of iterations and the whole thing gets recomputed, so we get all the detail back. So like this. Yeah, so we are going to do this with Pygame. So I'll just install it in here. And as you can see, I've set up a new project file for this whole thing. Well, the main reason is I want to keep this main.py file right here because it generates like an image of the Mandelbrot set. I can specify the range, what dimensions the image should have, the iterations and all. I think it's just good to have, or I don't want to ruin the file now. And we'll write the whole thing in a new file because we're gonna have to do a lot of things separately and or like differently, I guess, to how it's done here. And if we need stuff like, for example, this function, escape time or the map range, we can just import it from this file, I guess. So yeah, this is why I'll start fresh with a clean slate so we can get all set up. Okay, right. So let's import Pygame and try to just get a window set up. Just an empty window where I'll draw a rectangle onto it. So we'll start by initializing the Pygame library. And then we can create the screen, which is going to be a pygame.display. And we set the mode. And yeah, we input the width and the height. So let's do 900 by 600 as some global variables. So width and height. And I think now we can move on to the game loop. So we create a variable called running that decides whether the app is running or not. And while it is running, we poll for events. So we do for event in pygame.event. I think get, yeah. And now, most importantly, we need to be able to close the window. So we check if event.type equals pygame. If it equals the quit event. If. And if it does, then we set running equal to false and we just quit. And in here we have pygame.quit. And I think this should, yeah, this creates an empty window. Okay, let's try drawing a rectangle onto that. So for this in the loop while we are running, I want to pygame.draw rect. Well, the surface we draw it on should be the screen. The color, make it red. Screen. And the position, or the rectangle, I guess, we can just pass in the tuple into this. So we do the top left corner. So let's just do 50-50. And the width and the height, let's do a width of 100 and a height of 200. So, and now we've drawn the rectangle to the screen. Now we also need to update it. So we do pygame.display and we just flip the display. And now, yeah, there we go. We see the red rectangle. Okay, so this is the basic setup for Pygame. Now comes the interesting part with multiprocessing. So let's import the multiprocessing. And I had a bit of a think on how we're gonna do this, and did a bit of research. As I said, I'm still very new to the multiprocessing library. So my game plan right now is to have something like this. So we have two conveyor belts. So in the code, that's going to be two multiprocessing queues. The first queue is going to be, I guess, like some input queue of tiles. So the conveyor belt basically moves into this direction. And we're going to have some function or something that's going to be a producer. And he's going to prepare some tiles that need to be processed. So just as we had before in here in the static function, we'll, so let me just close that. Not compute tile, get tiles. We have something like this that'll return some array of tiles. And in the context of this example, it's going to be this conveyor belt full of tiles. Then in the middle, we're going to have the main logic. This is going to be what's going to be done by multiprocessing, is to compute them. So there's going to be some consumer. He's going to take these tiles, perform the computations to see whether they're part of the Mandelbrot set, what color they should have, and so on. And then put them onto this conveyor belt that I guess goes into this direction. So when they're done, I don't know, make them yellow. When they're done, they go into this conveyor belt, which again is going to be a queue. And in here, we're going to have some other function, maybe draw. And he's going to take these tiles and draw them to the screen. So right here. So this is the basic setup we're going to have. Yeah. Okay, so let's actually try to get it set up. So also what I'll do is I'll wrap all this into a main function. Because as far as I've understood it now, let me just write that out, main. Multiprocessing has like an internal check to see whether it would be like run if I import this as a package somewhere. And if I don't put it in a main function that's wrapped into this expression here, it'll throw an error. As far as I've understood it now, but I mean, it's good practice anyway, so might as well do it. Okay, so we're going to, let's just define these functions now. We're going to have a produce function, a produce tiles function. Then we're going to have the, I'm not going to call it consume tiles, let's compute tiles function. And then we're going to have a draw tiles function. So those are our three workers in this image here. And now all of them need access to the conveyor belts, basically. And the conveyor belts are going to be multiprocessing queues. So we are going to have a tiles queue is an mp.queue object. And we're going to have a draw queue is also a queue. Now they need access to this. So the produce tiles is going to ask for the tiles queue. the compute tiles is going to ask for both. So because it's going to take from the tiles queue and put on the draw queue, tiles queue and the draw queue. And the draw tiles only needs the draw queue. So, okay, let's start with the produce tiles. And I think for that we can actually, at least for now, yeah, copy from here. So let's just get this over. Put this into the produce tiles. Okay, we need to define a tile size. Yeah, let's stick to 64 because why not? And then, well, we don't need the tiles array here because basically we're going to put on the tiles queue. So we go through the whole thing and we make these tiles. And you know what, just for the sake of I guess efficiency, and also I'm not sure whether multiprocessing is going to like. I mean, I guess it liked it here that we worked with tiles. And because here we also use the tiles. I mean, okay, let's stick with the tiles. Okay. So then what I'll need though is from main import, we'll import the tiles, tile. So, and instead of the tiles array, what we do is we do the tiles queue and we put it on the tiles queue as the syntax for that. And then we don't need to return anything. Okay, so this produces us the tiles on the queue. Then we have the compute tiles. Now, the way this is going to work, and again, I did some research. Basically, the naive way of or how I wanted it to do it first is to have something like this, to have, let's call the process P, mp.process, and that then gets, I think it's called target, and then it gets the target function, which should be processed. It gets the compute tiles function. And then what we would do regularly is something like p.start. We'll start the process. And then when it's done, we end it. So p.join. So, and now we could do it for, I don't know, like 5 or 10 processes and whatever. Now, the issue with this is it creates a lot of overhead because all these processes have basically the separate Python interpreter, and we have to create it, and then we break it down just to create it again if I resize the screen. That's not going to be very efficient. So instead, what we're going to have is that the process just runs all the time, or like we're going to set up, say, I don't know, 5 processes. They run all the time, and then when I want to quit, I just give them basically some special like argument. So what we'll do is while true, so true, so just compute them, just all the time, just try to compute something. We do the tile is just take something from the tiles queue, and so we get it from a tiles queue. And so as far as I've understood, if this is empty, then it just returns nothing, and then nothing happens. But as a way to tell it to gracefully stop, so we can like bring the whole program to a halt without having to just kill it, we do if tiles tile. I mean, I guess okay. We do if tile is none, we break out. So basically, the none is like the special keyword or the special thing we're going to put on the queue, and if it sees a none, it's all right. I'm done. Process is over. But if it's not, we'll compute the tile. So now I'm not going to worry about drawing the Mandlebrot set already. Let's just fill the screen with colorful tiles. And then we can worry about the Mandelbrot set. So let's import the random module and define a color. So I have some color is random dot, actually it's going to be a tuple random dot rand int from 0 to 255 and make it 3. So we'll have some random color. And now we're going to fill the tile, because remember the tiles have these pixel arrays, and we're going to fill them. So for I in range tile.I and tile.I plus the width. Yeah. For j in range, basically the same for the j. Tile.j plus tile.the height. And I guess here we would then compute something for this tile, but for now we're just going to assign the color by accessing this color. So we just do, so yeah, I guess we just append. So we do tile.pixels append and just append the color. So okay, and now what we need to do is we took this tile from the left conveyor belt, we've processed it. Now we just drew some random color. Now we need to put it on this other conveyor belt. So what we do now is, once we're done with this tile, is we do the draw queue dot put the tile. So just put it on the draw queue. Okay, now imagine we have some tiles on the draw queue, and now let's draw them to the screen. So, and the thing is, we need to be a bit careful, but we can be smart about this. Because what we'll do is we'll call this draw tiles each frame here. Draw tiles right here of, and yeah, we can give it the draw queue already. But we only wanted to do it something if there are fresh tiles. If there's nothing new to compute, then, or like, how should I say, we only need to recompute the tiles if I change the view. You can actually see it in the application here. If I zoom in, you saw how the tiles got computed. If I'm just sitting here, I'm just looking at it, I don't need to recompute them, nothing changed. Only if I move something, then you see the tiles get new tiles. So what we'll do is, while the draw queue, well, I guess while it's not empty, we'll get the tile. So if it's empty, then this function does nothing. Then we don't change anything because there's nothing to change. So we do tile is drawQ.get. And here we don't need to check anything, I guess, because if there's nothing being produced, then there's also nothing being drawn. So there we don't have to check anything. Okay, now we draw the tile. And because we append the, I mean, that's so far it's actually pretty similar to what we did in the main function here with, let me just close all these with the compute tiles, or the draw tiles here. Because we put the tiles in order, we can also draw them. So yeah, I can just copy this right here. Yeah, the tile is whatever we get from the queue. And yeah, okay, I guess before we use the pillow library, now we use Pygame. And I think the easiest thing would be we just pass the screen in here. So let me just do it down here before I forget as well. Screen. And instead of put pixel, what we'll do is we'll have a surface. We'll kind of keep the index, that's fine. we do a surface is a pygame.surface. Basically like a new screen that we can draw on. And then we can draw this screen onto our proper screen, basically, is the idea. Well, yeah, you want a size. You're going to be tile.width and tile.height. And now instead of put pixel, we do surface dot. No, was it set at, I think. Let me look it up. So we do pygame surface set the color value of a single pixel. That looks good, yeah. Yeah, okay. I mean, we could just fill it now because the entire tile is gonna have one color, but let's implement it like this, that the draw is actually working, because then we only need to change the compute. So set at I and j, and the color is whatever the index gives us. But because we use a surface now, we basically renormalize them, so we don't need this. So we start at 0 and go down to width and height. Yeah. Okay, so now I've drawn everything to this other surface. Now I need to draw the surface on the screen. So I would use screen.blit, I think. And we blit the surface on the screen. And where do we want it? Well, where the tile starts. So with tile.I and tile.j. So basically, we took the offset out of here, and now we have to put it into here. I guess we could have also just drawn like 1 by 1 rectangles to the screen. Then we could have kept the offset in here, but yeah, I think this should be fine. Okay. So, okay, we have our produce tiles method that puts tiles on the queue. We have the compute tiles method that takes from the tiles queue and puts on the draw queue. And then we have the draw tiles method that just, if there is something to take, it takes from the draw queue. Okay, and now we can implement the processes. So what we do is first, when I first start the thing, I want to have some tiles produced. So I'll call produce tiles and pass in the tiles queue. So, and now I can create my workers, basically. So we have something like workers. We'll have an empty array. This is well, we'll put them. So let's create workers. So for blank in, so I don't know how many do we want. Let's say 5 for the beginning. We do a process is an mp.process. So now, what's the target? Where should it work? Well, at compute tiles. But now the compute tiles takes in two arguments, 2 inputs, the tiles queue and the draw queue. So we need to pass them as well. And we do it by defining args. So we do the tiles queue and the draw queue. I think that was tiles queue and draw queue. That's the order. Okay, so he's got it. Now let's p.start and just append it to the worker so we can like access it later. Now, I think this should actually already work, but now we might have an issue if we try to exit. So if we call if we're out of the loop, if we're already quitting Pygame, let's clean up our multiprocessing thing. So first, what we'll do is we'll send this keyword, this none, into the tiles queue. So, and we'll send it like 5 times. You know, actually, let's define this as like a number. So, because if I ever change the number of workers, I also want to change the number of keywords that I send. workers is 5. Yeah, let's put just before this messes up anything. So if we quit Pygame, we can do 4 process in the workers. No, actually, before we do that, we send them the keywords. For blank in range the workers, so every worker gets 1. We do the, what was it, the tiles queue dot put none. So there you know, okay, day's over, we're done, let's go home. And then we can join them. P.join. So because we can only join them if the work is done. Otherwise, this while true just keeps them busy. Checking if it's true. Yeah, yes, it's true. So yeah. Okay. Now, I know we've written a lot of code and we haven't started the application for other like 20 minutes. So there is a good chance this is not going to work, but let's see it. Oh wow, it worked first try. Okay. Yeah, that is exactly what I wanted actually. Yeah. Yeah. And okay, now at least now also another good thing, another good message. It's not crashing because I again did some early testing, as I said. What I had there is that, yeah, okay, the application opened, but after like 2 or 3 seconds, it just crashed. Probably because I messed up something with like memory, that I kept on putting stuff on the queue and never consuming it, or I don't know. So that's good. It's not dying. Can we close it? Yeah, we can. Okay, wonderful. This was at least for me the hard part, to get the multiprocessing on. So now I think we might as well start computing the Mandelbrot set. Okay. I'll collapse these 2 functions because those we don't need. What we'll need in here though is the Mandelbrot stuff. So in here in the compute tiles, yeah, let's just take this and get it into here. We can lose the color. I'll move you down and we'll input it here. So, okay, yeah, obviously you want the functions to will import map range and what was the other one? Get escape time. Yeah. Okay, and now for the color, I mean, yeah, you know what? We need this interpolate here, yes. So import interpolate color. But what I'll do is I'll put this in a separate function, like def get color of some escape time. And the way we did it, if let's think back, it was if it's negative, because if it's part of the set, we return -1, so it's smaller than 1. If escape time is less than 0, we return black, and else we return this monstrosity that I came up with. Okay, yeah, okay, we need white. Yeah, okay, I'm not gonna import them because that's just a number. We do 255, 255, and 255, and the same for black. And we'll want to know the max iterations. Let's just do 100 for now. Yeah. Do we also need the escape radius? I mean, like, it doesn't complain, So I guess, I mean, I'll write it down just in case. I don't know. Actually, I think that because it's defined in the main, it takes whatever. 2 is fine. We're never going to change it anyway because 2 is the minimum that it can be. Okay, so we set the color, or we get the color. So in here we do color equals get color of escape time. Yes. Okay, and then we just append it to the pixels, and we put it on tile. And I think this actually should work already. Oh, there you go. Yeah, yeah, that looks good. Yeah, that looks good. So that's exactly the image from here, just squished a bit, and the color's a bit different, I guess. Okay, wait. So let's. Yeah, okay. We need to renormalize this. So from -2 to 2, and again. Yeah, -2 to 2. I know. I remember that technically this should be flipped, but since it's symmetric, I'm not gonna care about that because I'm just gonna forget it. Okay. Oh yeah, and because it's squished, we had this issue last time. We also need to squish that. Yeah, let's just have a square aspect ratio again, and there it is. Wonderful, and you can see how the tiles grow. Because that's the good thing about multiprocessing and the queues, is we can put stuff on the tiles, and then already start computing them while the tiles are being put on the queue. And the same thing, we can start drawing them while we are still computing other tiles. This is why we use the queues. Oh, this looks good. This looks so good. Let me just... Yeah. Great. Okay. Okay. That's that. So now all that we need to do is implement the zooming. So, I don't think I'm going to implement zooming with the mouse wheel. Let me just go back down a bit. Zooming with the mouse wheel and panning. At least not in this video. Maybe I'll do it on my own time and I'll upload some progress somewhere on the channel. But I think for now what we can do is just have like a click, that if I click with the left mouse button, it zooms in around that point. So then let's take a screenshot of that so you can see what I mean. So my idea would be that, I don't know, I click with the mouse somewhere here, and then it gives me a new rectangle, I don't know, at some size around that point. And then okay, we zoom in, and this is the new view, this rectangle. And then again, I can click somewhere. What's the green? I can click here. And then it would do a new rectangle, something like this. And this would be the idea. Then if I don't know, if I right click, we'll zoom out a bit. Yeah. Yeah. Okay. Let's do this. So in here, when we poll for events, what we'll do is if event dot type equals a mouse button down. Well, first then we can print hey. So there's the set, and if I press my mouse, I get hey. So I can even scroll, or I can just press and I get the hey. Okay. So and I think I can access the keys with, let's print Pygame.mouse. Yeah, get pressed looks good. Yeah. So this gives me, if I press left mouse button, it's true, false, false. Right is false, false, true, and then the middle one. So it just shows which one is pressed. So, okay. So if left mouse button, zoom, and if right mouse button, then what's the opposite of zoom then? Oh, I guess zoom out and zoom in. So, okay, so if pressed of 0, if it's left mouse button, we do something. And if it's the first one, we do some other thing. Okay. Now let's think about the math of this. I'll delete you. And let's think about the math. So no, let me block it off. Okay. And we'll just stick to a square screen again, just for simplicity. I don't want to drag out this video any longer than it needs to be. We have already a 3-part series on this, so let's get this done. So we have some square screen that right now gets mapped to what was it, -2 and 2. So this is -2 and 2. Well, 0, 0 would be somewhere here. So this is 0, 0. Then this is 2 and 2, and 2 and -2, and -2 and -2. Okay. And now I want, if I click here, I'll want some new rectangle. Yeah, okay, let's take it one step at a time. Let's just get the mouse post. So print, no, actually get the, I mean, we can get the mouse post before. Pos, no, mouse pos is pygame get, no, dot mouse dot get pos. So print mouse pos. So if I press now somewhere, I get the mouse pos. So down here, 900 by 900 and 0, 0 up here. Okay. I feel like the first thing we should do is transform the mouse pos into like X and Y coordinates. So mouse X is map, and again, we can just map it. We get mouse pos of 0 coming from a 0 to the width, and okay, so currently it would be -2, 2. So we map it to -2 and 2. And I guess, we could print mouse X. So right here we have somewhere 0, 0, or like 0. Then here we have 2 and -2. But the issue would be now, okay, imagine that we zoomed in. Now we are in here. And now we have, I don't know, whatever, minus 1.5, 1.5, whatever. Now that value needs to update. So we actually need to keep track of our range right now. So maybe up here, let's call it the view is in the beginning, it's -2, 2, -2 and 2. So this is like X min, X max, Y min, Y max. Yeah. So target min is view of 0, and then view of 1. So remap it to this. Okay. Now what we do is I want to modify the range in a way. So how about we say if I zoom in, let's halve the range. Let's say, yeah, let's halve the range. So if it was 4 before, now the range should be 2. So we do yeah, let's do like a new range is, well, the old range. So view of 1 minus view of 0. And let's divide it by 2. So it's going to get smaller. And now, now this should, yeah, now we should just draw along that new range. So how do we do that? Well, also it should be centered around. Yeah, okay. So yeah, look at, okay, so this is our new range, this brown line right here. That's new and our new range. And we want the because the range is just the width. It doesn't have like a position in space. It's just the width. Now we want this point, or like, so we want these points to now be aligned in a way so that they have this range, and then also for y, I guess, and that this point is in the center. Okay, so what we do is I guess we do mouse X. That's going to be like the center. And then, yeah, we just subtract new range over 2. And then mouse X, and then we just add new range over 2 to the X. And that's our new range. Because, well, that point is this point minus half the range in X and then in Y as well. Yeah, okay, so, okay. So what we do is we say view equals, so we just update the view. So that's the new X, and your new Y is the same for Y. Mouse pos of 1, you get mapped to height. Now on this nothing changes because we don't actually change the dimensions of our window. What changes is this view thing. So now view of 2 and 3 in here. New X range, and the new Y range is view of 4 minus 3. Again, let's just say we halve it. New X range. Yeah, and then now we just do the same here. We do, yeah, mouse Y is this. So can I? Yeah, mouse Y. And then plus minus new Y range over 2. And we change one of them to a minus. Yes, okay. Okay, so we change this variable view now. Here. But now we also need to tell like the whole like conveyor system, hey, we've changed the view, like produce some new tiles, compute new the menu and so on. So we need to tell the producer that we did new tiles. So that's the new view, and then we call produce tiles onto the tiles queue, and I guess we also have to pass in the view. So the produce tiles now also asks for a view. Mm-hmm. Or does it? Wait, hold up. What? No, it doesn't. I don't think it does. No, it does. Okay, look, so the thing is, we can't change, then we would have some need, so we need a way to pipe this information about the new view into the compute tiles. Now, okay, maybe we could have something like a new queue, like a view queue, or something like this, and then have something similar for this. But I think the easiest thing would be to just give the tiles the view. So instead of putting on the because the tiles don't really change actually. What changes is the view. So we put in the tiles and maybe pass it as a tuple tiles, and then each package will also know like what view it's coming from. I guess. I don't know if this is the most optimal one, but this is, I guess, the simplest one for now. Okay, so, but then what we put on the queue is not the tile, let's call it a package. Package. If package is none, then we still break, and now we unpack that package into a tile, and the view is the package. So we just unpack it. Okay, and now we just need to adjust this map range here. And I guess we can just copy that, because the view's changed. Okay, I guess not, wait, hold up. Yeah, okay, whatever. Let's just do it manually before I break something. So you are view of 0, you are view of 1, you are view of 3, and view of 4. Yeah. Let me just adjust it a bit. Just so it's a bit more readable. So like this. So yeah, from the map I, from this interval onto this interval. Okay. But now, I guess we also, yeah, no, actually the view is defined here. Let's just, let's just give it a shot. Let's see how it works. Or like if it works, I guess. Missing one, oh yeah, oh yeah, we need to give it up here as well, so the view. List index out of range, yeah, where did I write 4? 2 and 3. Did I view of, yeah, look, I know myself. Alright, okay. Glad we caught that. Right, run it. Oh, now the terminal died, okay. So give me a new one. No, actually, don't. Open up a Python terminal. Okay, I'll worry about the layout in a sec. Oh. Okay. Oh, would you look at that? Okay. It's still a bit slow, but okay. Okay, wait. So give me 1 second. Let me fix the terminal. Okay, it works. So we can zoom in. It looked to work. I didn't double check, but I think it works. Okay, now we also need a way to zoom out. I mean, I guess what we could do, you know what? Let's just bring this up here. Because then if we zoom in, we just halve it. Then how about if we zoom out, we just double it? So let's have a scale. So if we zoom in, we scale it by 0.5. Else we scale it by 2. so. And then we can get you a level, indent this out. And then in here, we just multiply it by the scale, and this should have done it, right? So I zoomed in. Let's zoom in again. Okay, and now I'll zoom out. Wait, what? No, I'm zooming in. Wait, hold up. Wait, no, I'm zooming in. Also, I'll just have an else scale equals 1, just because I think now also the scroll will trigger the zoom and then it doesn't know what to do. What? This should work, shouldn't it? You know what? Let's just for debugging purposes. You know what? I'll bring back the get escape time. Just to get it up here, just so I can like change the iterations, because now, oh yeah, because now it does 500 iterations, whereas I think we're good with 100 for now. Can you run, please? So, okay, and then also let's get this out. Oh, and wait, what? Did I not terminate this? Okay. Okay. I'll look into that in a second. Oh, that's more like it. Okay. Why do I keep zooming in? Actually, no, wait, never mind. I am zooming out. Just. Or am I? No, I'm not doing anything. Not. Huh? Let's see. Zooming out. See, it doesn't even, because I'm pressing. Oh, because it was 3. Wait, hold up. Yeah, see, now with the mouse, I can zoom out with the mouse. It was the third like element, not the second. Oh no. Wait, what? Wait, now I'm confused. Print pygame.mouse.get pressed. Wait, now I'm confused. Left. Yeah, and here true before we got the error. Okay, so it's the second one. Okay. Close this. Oh god. Okay, zoom in. Oh, and zoom out. Okay, wonderful. Okay. Okay. Okay, I hope I'm not frying my computer with having some multi-process open. Oh yeah, also actually what we could do to increase performance, how about we increase the number of, because I think that works for now. That works. That all works now. How about if I increase the number of workers to, let's say 20. Let's just go all out to 20. Again, I have 32 threads, so should be fine. Oh, that is quick. Oh, would you look at that? Oh, that is good. Okay, now what if I increase the tile size? Because if you like caught it, they're still relatively small. Is this faster? I'm not sure. I think it actually is. But you know what? I actually like the smaller tiles more than this like transition of drawing the new tiles is a bit smoother. I like them more, I guess. Okay, final thing. I know this video is getting long again. I've been recording for an hour almost. Let's implement the some way to increase the iterations. Let's just okay, for this, what I want to do is I want something that says, you know, how many iterations we have right now. Pygame display font, like text font or something. I'm not sure how to do it. Oh yeah, I remember we need to initialize like the font module. I'll just go on Stack Overflow. Yeah, that looks about right. Okay, so let's initialize the font. I'll collapse you and yeah, maybe let's initialize the font here. I think we can just ignore that. Can we? I guess. Well, let's try. Let's see. Okay, I don't want to write it in Comic Sans. Okay, and then okay, actually, I guess we need it because that defines the font. So, what was it? Sys font. Create a font object. Yes. That is loaded from the system. Will match the requested bold italics flags. Okay. You know, let's just try Comic Sans. Let's see if it works even. Yeah, I think no app font. Let's go app font. Let's try Comic Sans. Alright, sure. And let's just write something. So we'll have like a surface, so we have the text surf is a surface. No, a pygame.surface. Because I think we need one, right? No, actually we can just okay, no, it creates a surface. And then we just screen dot wait, I'll blit it here after we draw the tiles. So we just do screen dot blit text surf. Okay, let's see if that works. At say 0, 0. Okay, that's about what I want actually. That's about what I want. Let's give it like a rectangle behind it, so it has like some kind of backdrop or something. Pygame.draw rect to the screen. Color let's do some lighter gray so we can see the font. And add 0, 0. And then let's give it a width of 300 and the height of 50 maybe. Okay, that looks really shitty right now, but okay. Well, actually, what we could do, can we have an RGBA rectangle? Let me see. Draw rect width. Yeah, RGBA. Can I just make it like translucent a bit? So let's have 0, 0, 0, and I don't know, point. Wait, is it? It's an int. So I guess the alpha value is also gonna be from 0 to 255. So let's do 100. 10? Oh, okay, or is it... But then why is it an int? No? Okay. How do I change the opacity? If using a tuple RGBA. Do I... Uh-huh. Okay. Huh? Do I need to set the mode of the... It might be that I need to set the... Actually, no. I know what... I think I know what's happening. Let's see if we can like... let's see. Actually, I think I might know what's happening. Let's do a pygame.time.clock. Let's limit the FPS real quick. Clock dot tick 60. 10. Okay, no, that's not it. See, what I thought, actually, like, what an issue that we are going to run into with like, having translucent rectangles is this is just gonna stack up, because we don't reset the screen right now, because that's kind of, I guess that would be kind of expensive, because I mean, okay, we would need to cache the tiles somewhere that we compute, and then we need to draw them again, but still, drawing a 900 by 900 screen, every pixel like anew, it's going to be a bit inefficient. So these semi-transparent rectangles are just going to stack up, so that sooner or later they're going to be like they're going to like add up, and they're not going to be translucent anymore. Okay, how about, I think, can I round the corners? I don't know, make it a bit nicer. Width, yeah, border radius. So let's do the rect and do border radius. I don't know, 3. Okay, that's it. Oh, actually, wait, I wanted it white. 25. Okay, that's better. It's better. It doesn't help that it's Comic Sans, but we'll fix that in a second. Let's do it at 25, 25. No, that's the text, sorry. Add here, 25, 25. 10 and 10 maybe. Okay. And now we do the same for the text. So 10 and 10. Okay. Let's see if I can change. Can I do computer? Oh, that's the wait. That's the text here. Can I do computer modern? No, it's CMU serif? No. Oh, it's the font. Let me look it up. Actually, let me go into, I don't know, Word or something. Let's see if I can find the font. Serif. Yeah, okay, I almost had it. Serif. Let's see if that works. Yeah, I can live with that. Can you make the aliasing on, or like the anti-aliasing? Yeah. Oh, this starting to look good. This is starting to look good. Okay. So we do iterations. We do some f string. Oh, let's change it to these. Let's be consistent with the quotation marks, at least. Iterations, and we do... Well, then I'll take it out of the max iterations of the global variables. So we have something like max iterations is, again, say they start with 100. But now we need to change that we render it every frame. So we'll put it down here below the draw tiles. Iterations is, it did not, oh yeah, because now it's not defined. Okay, wait, hold up. Let's do max iterations. Let's be case sensitive and let's replace it with max. Okay. Actually, but okay, now they would need to. That's fine though. So let's do max iterations. Let's just pass them through. So what did I change? The get color and the escape time. So okay, that's fine. And the compute tiles. Get color gets the max iterations. I guess I'll need to pass it in there as well. Oh boy. Okay. It's gonna be like a piping nightmare, but okay. I'm down for it. Okay. Okay, so we pass it in. The escape time also needs the max iterations. So let's just put it in the package. So max iterations, just put it in the package. So in the produce tiles, we'll also ask for the max iterations. I'm sure there is a better way of. I mean, probably couldn't I have just left it as a global variable and then I guess updated just like within the scope. Yeah, I guess. I mean, I guess this would be the more general example if we try to remake it in other languages where the global variable, or if I would define it as some constant in C, for example, something, that I wouldn't be able to change it later. So then I would actually have to do this. So max iterations, and we just put in, so let's just have it like this, tile, the view, and the max iterations. I'd be surprised if that works now. Oh, yeah. Process now isn't. See, that's the great thing about multiprocessing. It. Oh. Produce. Oh yeah. Okay. Produce task. Okay. Okay. That's fine. So that's fine. Now the produce tiles needs the max iterations, and now here if I called as well, we do the max iteration. Okay. Okay. So it works. I'll just quickly change that a bit, it's like to 15 maybe. Yeah, and move it in. Let's do 20. Oh, we can do 25. Okay. Okay. And now what I want is to have some. Let's do it with the arrow keys. Okay, so if it's mouse button down, handle zooming, and here we'll do adjust iterations. If event.type is pygame and now we do key down. So if event.key equals pygame.key, how do I do the up arrow? Up? Is it just up? Let's see. Print up. Okay, okay. So it's just up, and I guess it's down for the other one. Key down. Okay. And I guess now all we need to do is, instead of printing something, you do max iterations. I like the. And I guess we take the let's just be safe and just take the integer part anyway. And yeah. So what I was about to say is I liked here that you double it, because as you go in further and further, you'll just need that much more of that. Yeah, you'll just need more and more iterations. Oh, this looks cool. But yeah. So let's also have double it. Okay, let's see. Oh, and oh, just before I hit that, and we have a breakdown again. So if it's key up or down, what we should also do is then call to compute the tiles again. So we do produce tiles into the tiles queue. From the current view, it didn't change, and the max iterations, but which did change. Okay, and I only want it if it's up or down. Okay, so let's try. Let's zoom in. Let's go in. I don't know. Let's go up here. Looks cool. Okay. Okay, and this now looks a bit rugged. You know, it doesn't look good. Let's increase. Okay, I just hit the key. It didn't do anything. Okay. I don't wanna push it. Just let me print up and down. Okay. Okay, that's it. Why do you not want to produce me new tiles? Is my question. I mean, it works here. If I zoom, then I call produce tiles and oh, well, it would help if I actually do something with the iterations. So max iterations equals that. Yeah. Again, I'll just keep the int part. It should matter because we'll just have powers of 2 or like multiples of 2. Now though, so again, I'll pick another spot. Let's zoom in into here. And now increase the iterations. Oh, would you look at that? 400. Oh, that looks good. Oh, just look at that. I don't know if you can hear it, but my PC is like starting to howl. And I love it. Oh, that looks good. Wow, I'm really happy. Damn. Okay, I'm really happy about this. Okay. You know what? Just as a, I think we're done here with the functionality. Now, yes, there is so many things I would love to change about this. I would like to have it in like a non-square aspect ratio, maybe. That I also calculate, you know, how I would need to adjust the X and Y range accordingly. It doesn't look horrendous anymore, but it's still not great with the just white rectangle and black text on it. And of course, it would be great if you could just actually like pan, zoom, and drag and mouse wheel and stuff. But I feel like that's beyond the scope of this video and this series. So we'll call it here. I just have one thing I want to try real quick. I did some research. Let's see if I can find the repo or the Stack Overflow discussion. So Mandelbrot set color scheme. Is it this one? I I found this discussion on Stack Overflow. Yeah, this one. To achieve this gradient that is apparently used for some fractal visualizer. Where does it say? Hey, ultrafractal. That's this color scheme to define it. And one guy, he has like a scuffed version, like a broken down version of this, to just have 16 colors that he picked here using Photoshop eyedropper. And I actually I do not have it anymore. Wait, let me see. Okay, I think I don't have that anymore, but I tested it, and we could also try this. So let's just quickly grab it and define colors as an array of those colors. And we convert them all into tuples. So, and now here in the get color, instead of doing this, I'll just comment it out. I don't know if I'll keep it or not, but we do, well, we, what do we do again? So I think we just do index is an integer of escape time modulo the len of the colors, and then return colors of that index. And I think that was it. Yeah. That's, again, this is like a broken down version, and there is also algorithms to deal with the smoothing. So he does an entire Wikipedia article about this. Here, continuous smoothing. There are ways how you can actually deal with, because what we do right now is a very quantized approach. So we check, well, did you diverge after 4 or after 5 iterations? And then we assign the color, and we could actually smooth it out a bit. But again, I think this looks good, and I'm not so sure about about this color scheme in like the messy regions, because there it just looks a bit strange, if I'm honest. But I don't know. I just want to try this color scheme and see if I like it. Okay, but yeah, let's just get this back. I think I'll call it here. This was very fun, very much fun to finally code the Mandlebrot set in Python. I wanted to do this for such a long time. I did have an attempt in C++ back when I had like a uni course, and it didn't really work. So I'm really happy on how this turned out. Let's just get the old one back. I'm not that convinced of this color scheme. So yeah, thank you very much for watching, and I'll come up with some other project for the next video.